Okay, so for this problem, we are given a deck of cards that is split into two different piles of 26 cards, and then we are forming the next deck by alternating cards from these two piles, starting from the bottom pile first. So the new deck will basically be of this form. The first card in it will be bottom pile index 1, top pile 1, bottom pile 2, top pile 2, etc. Now we are assuming that the card begins in the seath position. We have two cases. C in top pile, which we will number as 1 to 26, if it's in the top pile, it's in one of these indexes, or bottom pile, which we will denote as 27 to 52. And depending on where C starts, it's going to be handled differently. So I will quickly number off the cases just to make it easier to follow. We have case 1 here and case 2 here. And then we'll start off with in case 1, we can note, given how we've kind of established a pattern here, the index 1 of the top pile was placed after index 1 of the bottom pile. Same thing with here. We can see that it will be placed in index 2C in the new pile. And we can note, given how we have defined C, that 1 is less than or equal to C, which is less than or equal to 26. So 2C is less than or equal, or is strictly less than, I'll put strictly less than 53. So we can note that this will just be equal to B, where B is congruent to 2C mod 53, because 2C is a value between 0 and 53. And then we have case 2 here, where, as we can recall, 27 less than or equal to C, less than or equal to 52. In this case, the value, or the card at index I in the bottom pile, so we are only considering the bottom pile, and we can note that it will be placed in the new pile before the card of the same index in the top pile. So as we kind of establish up here, the card at the index 1 of the bottom pile, which would be 27, was placed first. The card at index 2 of the bottom pile, which is 28, was placed second. Was placed third, and that pattern will continue across the entire pile. So the general pattern that we are detecting here is that if a card starts at seath position, in this specific case where 27 is less than or equal to C, less than or equal to 52, it will be placed at 2 times C minus 26 minus 1 in the new pile. And we can verify, like, the card at 27 will be at 2 times 27 minus 26 minus 1 equals 1. And as we establish here, that is the case. Similarly, 2 times 28 minus 26 equals 2 minus 1 equals 3. The 28th card does go 3 in the new pile. That is our general pattern. And then we have that 2 times C minus 26 minus 1 equals 2C minus 52 minus 1 equals 2C minus 53. This is a multiple of 53, and this is 2C, which is congruent to 2C modulo 53, which is what the question initially was asking. Now I have pasted part B again here, and we are going to be dependent on part A to solve it. We can note that given part A, if a card starts at C, it goes to 2C mod 53. If we know this, we want to find nx, we'll say the minimum x, such that 2 to the x times C mod 53 equals C mod 53, which is only possible if and only if 2 to the x equals 1 mod 53. So in other words, we want to find the order of 2 modulo 53. So to continue, I've obtained some identities from elementary number theory by Kenneth Rosen. We know that if P is prime, then its Euler phi is going to be P minus 1. We can note 53 is prime. To prove rigorously, check if any prime less than or equal to root 53 divides it. That's an exercise you can do, but that's pretty easy to show. And then we can note that the order of 2 modulo 53, given this identity here, we can note that order of 2 modulo 3, or modulo 53, divides this value. And because this is prime, this is going to equal 52. So now we can check the divisors of 52. The divisors are in this set here. 1, 2, 4, 13, 26, and 52. If none of these if none of the first 5 values satisfy this property, then we know that it must be 52. And I'm not going to go through all the calculations, but we can just quickly write down here that is not congruent to 1 mod 53. Same thing here. All the way up to 26. Therefore, the number of shuffles must be 52. And that's all we needed to do, so we are done.